Hi guys, I'm live again, or still. Almost didn't do this video, but it's a thing, so I think I will. I guess I'm right because I'm doing it. I wanted to go on about my birthday even more than I have before. I know I've talked about coincidences or non-coincidences about my birthday relating to Randy Rhoads, Steve Vai, and Paul Gilbert, and I'll probably reiterate this too. The Bible's mention of 666 being the number of the Antichrist or the beast or whatever. But I haven't talked about, and I just want to go on a little more about its possible connections to geometry and physics and math. So I've got with me my copy of the Quadrivium. Whatever I read from here, I will state is not my own thought. I will say that I will say when I'm reading this that I'm reading it, and hopefully I will be reading it when I say I'm reading it and I'm reading it. Quadrivium. It's the four classical liberal arts of number, geometry, music, and cosmology. Number is just number. Geometry is number in space. Music is number in time, and cosmology is number in space and time. That's my own addition, but that's what they say in there too. Okay, so first of all, a little review of geometry. It just so happens that if you take a circle, you can fit exactly six circles around it tightly, and that's not a good drawing of that fact. Jeez, man. Oh, I think this moved a little. One circle in the middle will support 6 circles around it. I'm a lousy drawer, but that doesn't change the geometrical facts I'm saying. 6, and that's not, 6 circles with one in the middle, and they all fit tight and all that. Just try it with pennies, you'll see. If you don't try, you won't see. If you try, you will see. Okay, so the numbers here are 1, 2, 3, 6, 6, and then the next number is 1, and the next number is 7. Okay? In this fact. And a lot of things relate to this. But before I go on and on about that, when you guys could probably Google it yourselves. I mean, what do you have? You have the 6 days of creation plus 1 day of rest is 7 days in a week. I don't know. There's just so many things. My birthday is 12/6/1966. As you can see, I have a 6, I have a 1, and they can add up to be 7. So far, my birthday is consistent with these numbers. It doesn't actually have 7, but it has 6 and 1, which is what the 7 comes from. The 7 is not its own unique thing. It comes from 6. 7's only unique because it's 6 plus 1 in my book. But I have 6 and 1 in my birthday. So that's a 2-dimensional example because I used the circle, which is a 2-dimensional figure. I don't know what a 1-dimensional circle would be because a 1 dimension is only a line and circles are 2-dimensional. But now if I have a 3-dimensional cube, well, I mean not cube, sphere, but spheres are 3-dimensional. Let's say I have a sphere. This is supposed to be 3 dimensions here. 3-dimensional sphere. I can put 12 other spheres around it. I can't draw that because this is a 2-dimensional board, plus I suck at drawing anyway, but there's 12 spheres that will fit around one sphere in the middle. Okay, so that's the numbers there are 12, 1, I don't need to put a dash, I don't need a dash. 12, 1, and 13. Okay, 12, 1, and 13 are important because 12 is the outside, 1 in the middle, and the total is 13. There's lots of inversion of places where this is important in math and stuff. I mean, all over the place, come on. I mean, you have the 12 disciples plus Jesus is the 13. Jesus was the 13th member of the cabal or whatever it was he had going. And Friday the 13th is unlucky because he died on Friday, and 13 is he's the 13th. I don't know. 12 notes in a chromatic scale, but if you add the octave, you get 13. If you start on a C and count to get to the next C, you actually count 13 because there's the first and the 13th are the same note, an octave apart. If you just take this individual notes, you have 12. But if you add the 1 as an octave, you would have 13. If you go C, D, all the way around, you come back around, and the first one, if you started on C, you'll end on C, and they'll actually count to 13. Well, let's look at my birthday again. My birthday is 12, 6, 1, 9, 6, 6. Well, I have 12 literally, and the one would, and I have a 1 right here, so I'm supporting this right here. There's other ways of getting 12 for my birthday, but let's just go on. So there's that. That's 3 dimensions. We are 3-dimensional. Well, we live in 4 dimensions. I think we are. How would you define that? We live in 3 dimensions plus time, so we live in 4 dimensions. So we're 4-dimensional beings, okay? I'm going to call it that way. We're 4-dimensional beings, so we can see 3-dimensional spheres. So we can see what I've just shown. But let's say we were 5-dimensional beings, and we could see 4-dimensional spheres, which I'll call hyperspheres. HYP, hyperspheres. Oh, that doesn't even look like I spelled it right. Spheres. Sphere. Yeah, there we go. Hyperspheres. I'm not sure. Somehow, let's just assume they exist. So maybe it's possible. And I'm going to use the quadrivium in a minute here to try to make this likely. Plus, I'm going to read about the other two. I'm going to read a little bit in the quadrivium. It's likely that if you have a 4th-dimensional hypersphere, since having a circle had 6 circles around it, having a sphere had 12 spheres around it, maybe having a hypersphere will have 18 hyperspheres around it. We don't know because we're only 4th-dimensional beings, but 5th-dimensional beings would be able to do this and see this. Let's just suppose that I'm a 5th-dimensional being, and suppose I can see hyperspheres. It's possible that if I have a hypersphere right here, 18 hyperspheres would fit around it. And then what would the numbers be? Let's just assume that. Let's just go with that theory. It's not proven, but then again, that's why it's called a theory. Definition of theories. And a good idea that's not proven, or at least an idea that isn't proven. Well, what if it's 18, and plus the 1 in the middle would be 9, and the numbers would be 18, 1, and 19. Let's look at my birthday again. I'm 12, 6, 1, 9, 6, 6. You literally see many ways of getting 18, 12 and 6, whatever. And then there's a 1. And there's even a 19, but that just means I was born in the 20th century. That's stupid. But 18, 12 and 6 or whatever, 1 and 19. Okay, that my birthday covers that. And then I'm going to read from the quadrivium, or maybe even write some of it on the board so you guys can actually see it. I don't know. We'll see how it feels, how I go with that. Let's see what the quadrivium says. 18 years is the solar. I'm reading from the page 331 of the quadrivium. 18 years equals the Saros eclipse cycle. 18.618 years equals revolutions of the moon nodes. 6.18 is phi minus 1. It's the golden ratio. Phi is the golden ratio, which is 1.618033996, etc. So phi minus 1 would be 6.180339990, etc. 19 years equals the metatonic cycle. There is a full moon on if there is a full moon on your birthday this year, there will be another one on your birthday in 19 years' time. So that adds credence to 19. But 18 is the Saros eclipse cycle. Similar eclipses will occur after 18 years. The eclipse year equals 18.618 times 18.618 days. The eclipse year is the time it takes for the sun to return to the same one of the moon nodes. It's 18.618 days short of a solar year. There are 19 eclipse years in a Saros. I looked at this and got it in my head, but who knows? 12 full moons equals 18.618 times 19 days. 12 full moons is the lunar or Islamic year. So the Islams take a year as just the literal number, the number of days it takes that the moon literally does revolve around the Earth 12 times. So it's less than our years. Because our years is the number of well, I'll read it here in a second here. The number of years that the number of full moons in one of our years is approximately 12.369 full moons. So we're not quite, we're between, we're between, our years are between the length of 12 full moons and 13 full moons. It's somewhere in the middle. The solar year equals 18.618 times 19.618 days. The solar year is the 365.4.242 day year we are used to. And full moons, 13 full moons equals 18.618 times 20.618 days. 13 full moons is another 18.618 days after the solar year. So if you take one of our years, which is 365.242 days, and add 18.618 days, you get the number of days in 13 full moons, whereas 12 full moons is the lunar year or Islamic year, number of days it takes the moon to revolve around the Earth 12 times. Our solar year is the number of, is between 12 and 13 times the number of days that the moon takes to revolve around the Earth. Okay. A lot of 19s and 18s, and 18s and 19s in that. And I know that may not be exhaustive, but at least there is a lot of that has to do with 18 and 19. And I may go back to that page, but for now let's shut it. But here's another thing. It's maybe a small thing, but let's just do it anyway. So what if there's a fifth dimensional sphere, hypersphere, I don't know, fifth dimensional sphere, where you could have a 5-dimensional sphere, and who's to say that maybe 24 hyperspheres or fifth dimensional spheres might go around one hypersphere, and then you would have the hypersphere in the middle, and then the other one would be 25. All right, get that? There's a fifth. Now this is a fifth dimensional sphere, which might have 24 other fifth dimensional spheres fitting around it, with the one in the middle making one in the middle, plus the total being 25. Where do you see that? Well, first of all, this is Christmas Eve, December 12. 24 is Christmas Eve, and 12/25 is Christmas Day, one day later. So it's literally in Christmas. Why'd we happen to pick that? I don't know. But maybe it comes, at least on some level, from the physics I'm talking to you guys about. And if I were a sixth dimensional being, I could see a hypersphere because I could see a fifth dimensional sphere. Okay. How does that relate to my birthday? My birthday is 12/6/1966. Well, 24. There's 6 and 6 and 6 and 6 and 12. Literally make 24 right there. There you have it. And then there's a 1 and 25. So my birthday covers that so far. All right, let's go to one more level. And beyond that, I'm going to stop. Let's say you have a sixth dimensional hypersphere. So I have a sixth dimensional hypersphere. Who's to say that won't have 30? Because 24 plus 6 is 30. Maybe it has 30 hyperspheres around it, and you have the one in the middle, and total makes 31. A hypersphere would be a sixth dimensional sphere, which could be seen by a 7-dimensional being. Remember, there's 11 dimensions in the universe, so you could probably have beings up to 11-dimensional beings, which means they could see up to 10-dimensional 10-dimensional spheres of whatever you want to call it. Where do you see this? Well, number of days in a month plus 1 sometimes, and 31. Sometimes you have 30, sometimes you have 31, but the one's the difference. And except for February, this is all the other 11 months. And there's also 11 dimensions. I wonder if that means anything. I don't know, whatever. Well, let's see. Oh, I don't want to erase that yet. Let's see, my birthday totals out on that. 12, my birthday is 12, 6, 1. Yeah, kind of even right. I'm glad there's more than just drawing as an art. Because, okay, 30. Well, 12, 6, 6, and 6. 6 and 6 is 18, plus 12 is 30. I've got that right there, plus the 1. That literally, except for the 9, that literally maps out my birthday. There's a 6, 6, 6, 12, 12, 6, 6, 6 is 30. The 1, 31. My birthday covers it. So my birthday has inside and out the number of all the way from circle to hypersphere. That is all the way from 4th dimensional beings to 7th dimensional beings, likely or possible theoretical versions of sphere, and then outside, and then count the number outside, and then add the 1 in the middle, and then count the total. So really, I just thought about that about my birthday. I wasn't going to do this, but then it kept nagging at me, like, well, you didn't do it. I know, maybe I'm not, but you didn't, and I decided to just do it. I explained something before. So it's interesting. I just think that the math of my birthday is kind of cool, I think. And plus, I was born on 7:13 a.m. That's when the day I was born. And 7 is 6 and 1, and 13 is 12 and 1. That's kind of funny. There's all these little coincidences. 6 and 1 is 7. 12 and 1 is 13. 6 and 1 is a total number of circles in and out that cover each other. 13 is the total number of spheres in and out that cover each other. 12 spheres cover 1 sphere, and the total is 13. 6 circles cover 1 circle, and so the total is 7. I don't even know if that means anything. I don't know, whatever. But I want to do one more thing before I go, while I have this board here, and while you're all bored. Just kidding. Not so much about my birthday, but I want to talk about about something in the quadrivium. They say there's 2 techniques to figure out. Let me think here. Yeah, to calculate the number of full moons in a year, in one of our years, number of times that the days it takes for the moon to go around the Earth. That would be the number of days in a full moon, because every time it goes around the Earth, it becomes another full moon. And that number would be between 12 and 13, as I said. And I'm going to go over 2 ways of calculating that, perhaps. 3, 6, 9. So here goes. All right, I don't need the book anymore. I've already got it in my mind. So let's do these. I got this from the book, but I'm not going to use the book to explain it. I'm just going to shut the book. The book is shuttish. All right, first way. Take a pentagram, which I suck at drawing. Now I do that one upside down. Let's not have an upside down one for the purpose of this. Let's have a right side up one. If I even know how to draw an right side up one. Then a circle. Okay, it turns out that if this outer thing is 13, if that's 13, then this distance, this covers from this thing to here, which is a little less than 13, because it doesn't go all the way across the main diameter, or the diameter. It crosses the circle, but not at the diameter. This length right here is approximately 12.364. And that's very close to the number of full moons in one of our actual years. Very close. I don't know what the accuracy was. It was very, very close. That's one way of calculating it. The second way of calculating it is this, and then we'll quit the video. If you don't like the video, then don't watch it, please. I beg you. No, I'm just kidding. There's another way of calculating it. What you do is you take, this is a Pythagorean right triangle. This is 12, this is 5, and this is 13. How do I know this? Because If the Pythagorean theorem says that c squared equals a squared plus b squared, don't write a 3 when you say squared. And if a is 5, then a squared is 25, and b is 12, and b squared is 144. That adds to 169, which is equal to 13 squared. So you have called a Pythagorean triplet, or Pythagorean try something, triplet, I don't know. 5, 12, and 13 make a right triangle. All right, we said that. Now, let's do this. Let's divide this 5 here into 3 and 2, because 2 and 3 make 5. Not only that, I'll go into that point I just about almost said later, just a little later. Okay, so it turns out that this line is a little shorter than this big line right here, a little shorter than 13, but guess how long that line is? This line right here, that line is 12.369. That's what it is. And that is even closer, very close to the number of full moons in one of our years. It's like very, very close in accuracy. We have about 12.369 new moons per year, full moons per year. And that's the number. That means that the moon goes around the Earth about 12.369 times in one of our solar years, one of our years. That's interesting. The last thing that's interesting about this, to me at least right now, is these numbers all kind of add in the Fibonacci sequence. I don't even know how to spell it. I could spell better when I was less of an artist and more of a mathematician. And now that I'm becoming more of an artist and a mathematician, I can't spell very well. I can't spell very well. That's a rhyme. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, etc. Each term is the sum of the two terms before it. Well, you see Fibonacci all over this. You see 2, 3, 5, 8, 5 and 3, 13 right here. 21 would be 13 plus this and this. Yeah, and so forth. You see a lot of Fibonacci. Fibonacci sequence goes a lot in just because the Fibonacci sequence approaches. Let's just do that one more time. 3, 5, 8, 13. The ratio of this to this, the ratio of this of one term to the term before it approaches the Fibonacci, approaches phi as you go further down the sequence. Eventually, like 13 over 8, and then the next one is 21 over 13. Next one is 34 over 21. You go far enough, eventually this ratio tends to become 1.618033399, which is the golden ratio. It just happens that Fibonacci sequence will do that. You go far enough, it starts to equal that. And that's called phi. It's a Greek letter, but it means the golden ratio. It's a thing. And like I said in another video, I'm repeating myself, but you see phi in all of nature. And a guy named David that went to my church, the church I went to, called At the Cross in Oceanside. I went there a little bit. In fact, I got baptized there. I wanted to undo my Jehovah's Witness baptism. And since I had that baptism after the Jehovah's Witness baptism, it had a feeling that, at least to me, that I was no longer Jehovah's Witness. I don't know what the truth of that is, but whatever. And David said to me, he was very intelligent, a very intelligent dude. And he said to me, what's the only example, the main example in nature, maybe the only example where you don't see the golden ratio phi and come into play. I said, what? He stumped me. I don't know. What? Tell me. He said, the human face. The human face has the ability to be ugly, whereas most living beings and things don't have that option. A starfish is a starfish, and they're beautiful. Every one of them. Dogs are dogs. They all look beautiful. Dogs all look beautiful. Birds all look beautiful. Fish. They all have a carbon copy. All look beautiful because they all go by the golden ratio. But the human face has the ability to not do that. The human face can be ugly, which means that means the uglier you are, the more God had to work to make you. Because if God just cut you out like everybody else, everything else, it would just be you're beautiful. But if God took time and worked at your face, what he does is muck up your face, make your face non-golden ratio-ish, make you ugly, and that means he worked harder to make you. I don't know what that means or implies, but he said it, and it's possible. Love you guys. Peace, love, and rock and roll.